Most airports are built on vast and flat plains, but today, we explore a masterpiece of engineering that sits defiantly on top of a jagged mountain peak. This extraordinary structure was built in a place where nature never intended for planes to land, surrounded by lethal cliffs and the world's thinnest, coldest air. Welcome to an in-depth technical report by Cintech Industries, as we dissect one of China's most incredible and daring engineering achievements in the modern era of aviation. To build here, engineers had to rewrite the rules of construction, facing terrain that is considered some of the most difficult and hostile on our entire planet. We will use advanced telemetry and digital twin simulations to understand the sheer scale of the transformation required to turn a mountain peak into a runway. Every takeoff and landing here is a battle against the elements, requiring precision technology and nerves of steel from the pilots who brave these high-altitude routes. The story of this airport is a story of human ambition, where the desire to connect distant regions overcame the physical barriers of the Earth's highest ranges. For centuries, the mountains of western China acted as an impassable wall, isolating millions of people from the economic heart of the nation and the world. Ground transportation across these regions can take days or even weeks, navigating treacherous roads that are often blocked by landslides, heavy snow, or massive flooding. To bring economic prosperity and modern healthcare to these remote locations, the Chinese government realized that the only way forward was to look directly up. Airports like Daocheng Yading were envisioned not just as transport hubs, but as vital bridges connecting the high-altitude plateaus to the rest of the global economy. The transition from mule trails to jet engines represents a technological leap that few regions in history have ever experienced in such a short period of time. But before a single plane could land, engineers had to solve a problem that seemed impossible. Where do you put a runway in a land of peaks? The answer was as radical as it was difficult. If you cannot find a flat space, you must create one by literally cutting off the mountaintops. This required the removal of millions of cubic tons of rock, moving entire sections of the Earth to create a stable foundation for the heavy aircraft. Construction began with a massive fleet of heavy machinery, transported piece by piece up narrow mountain roads to heights exceeding 4,000 meters above sea level. The workers faced extreme physiological challenges, as the oxygen levels at this altitude are nearly 40% lower than what is found at the sea level. Week after week, the profile of the mountain changed. What was once a series of sharp, uneven ridges gradually began to take the shape of a runway. Engineers used complex algorithms to balance the cut and fill process, ensuring that the rock removed from the peaks was used to fill the nearby deep valleys. Each layer of earth had to be compacted to extreme specifications to prevent the ground from shifting under the immense weight of a fully loaded passenger jet. Progress was often interrupted by violent weather, where sudden storms and freezing temperatures could halt the pouring of concrete for several days at a single time. Special additives were mixed into the concrete to allow it to cure properly in the sub-zero temperatures and high UV environment found on the roof of China. The scale of the earth-moving operation was so vast that it could be seen from space, a permanent scar on the landscape, becoming a symbol of progress. Finally, the foundation was ready. The mountain had been tamed, and the engineers had created the highest flat surface for miles in every single geographic direction. Thousands of sensors were placed within the ground to monitor for any tectonic shifts or permafrost melting that could threaten the integrity of the long runway. As the final markings were laid down, the focus shifted from civil engineering to the complex physics of flight in the extremely thin, high-altitude atmosphere. At 4,000 meters, the air is thin. This means there are fewer air molecules to provide the lift required for a heavy plane to take flight. To compensate for the lack of lift, high-altitude airports require runways that are significantly longer than those found at sea level to allow for higher speeds. A plane must travel much faster on the ground to achieve the same aerodynamic lift, making the takeoff and landing phases much more critical and highly sensitive. Engine performance is also affected. With less oxygen available, engines produce less thrust, and the cooling systems must work harder to manage the extreme internal heat. Landing is equally dangerous. Because the air is thin, the aircraft's true airspeed is much higher, requiring more braking force and longer distances to come to stop. Modern avionics and satellite-based navigation are essential here, guiding the pilots through narrow mountain corridors where there is absolutely no room for any pilot error. For the passengers, the experience is unique. As they step off the plane, they are immediately greeted by the thin air and the majestic, cold mountain environment. Every flight plan is meticulously calculated, accounting for the unique air density and the complex wind patterns that swirl around these giant rock formations every day. The airport's weather station is one of the most advanced in the world, constantly monitoring for sudden changes that could make flight operations unsafe for travel. Ice is a constant enemy. In the high mountains, temperatures can drop 40 degrees in a matter of hours, turning a clear runway into a sheet of glass. A dedicated fleet of de-icing vehicles and snowplows must be ready at a moment's notice to keep the lifeline of the airport open and operational. The lighting systems are specially designed to remain visible even in the thickest mountain fog, guiding planes through the darkness and the unpredictable winter mountain weather. Regular inspections are vital, as the extreme temperature cycles can cause the concrete to expand and contract, potentially leading to dangerous structural failures in the runway. On the aircraft themselves, specialized heating elements are required to ensure that all sensors and control surfaces remain functional in the biting high-altitude mountain cold. Operating here is a testament to human resilience, proving that with the right technology, we can operate safely in even the most extreme environments on Earth. Beyond the runway, the terminal functions as a self-contained city, providing everything needed for survival and comfort in a place where resources are extremely scarce. The architecture is a blend of modern efficiency and local cultural aesthetics, designed to withstand high winds and heavy snow loads while remaining visually stunning. Passenger well-being is a priority. The facility includes medical stations and oxygen lounges to help travelers deal with the effects of altitude sickness during their stay. The heart of the airport is the control center, where advanced communications systems maintain a constant link with aircraft and other airports across the entire country. Powering such a remote facility requires a mix of local renewable energy and massive backup generators to ensure that the lights never go out during a storm. Water is managed with extreme care, using advanced recycling systems to minimize the environmental impact on the delicate mountain ecosystem that surrounds the entire airport facility. Safety teams are trained for the unique challenges of mountain rescue, equipped with vehicles and tools designed to operate in sub-zero temperatures and very difficult terrain. Every aspect of the operation is a feat of logistics, from fuel delivery to food supplies, all brought in through the same mountains the airport conquered. As night falls, the airport remains a beacon of light and connectivity, a testament to what is possible when engineering meets a vision for a connected world. These mountain airports are more than just infrastructure. They are a symbol of human ingenuity reaching for the stars while standing on the roof of world. They remind us that no barrier is too high and no terrain too difficult when we apply the full power of modern science and engineering to progress. Cintech Industries, engineering the impossible. Join us next time as we continue to explore the most incredible technical wonders of our modern world today. Behind every great structure are the people who dared to dream it, the ones who saw a mountain and decided it was the perfect place to fly. Thank you for watching this technical deep dive into the world of high-altitude aviation. We hope you found this journey as inspiring as the engineers did. The connection provided by these airports has transformed lives, bringing the world closer to those who live in the shadows of the highest peaks on Earth. Each successful landing is a quiet victory, a confirmation that the thousands of hours of planning and construction were worth every single bit of effort. As we look to the future, the lessons learned here will pave the way for even more ambitious projects in the most remote corners of our planet. Innovation is the engine of progress, and at Cintech Industries, we are proud to document the incredible journey of building the impossible in the high mountains. The mountain airport stands as a silent sentinel, a bridge between heaven and earth, and a testament to the enduring spirit of human exploration and discovery. The sheer power required to lift a metal bird into such thin air is a marvel of thermodynamics and engineering that pushes the limits of modern physics. Maintaining a safe internal environment for passengers while the outside pressure is so low requires advanced life support systems integrated into every single modern aircraft. Even the water runoff is a complex engineering problem, requiring a network of heated channels to ensure the runway stays dry and safe in all seasons. Chemical engineering plays a silent but crucial role, with specialized fluids designed to lower the freezing point of water and keep the flight surfaces clean. Understanding the mountain's core was the first step, ensuring that the foundation of the airport was built on stable, ancient rock that could support the weight. Heat management is a constant challenge in the sub-zero environment, where every watt of energy must be used efficiently to keep both people and machines warm. In this vast wilderness, the airport is a lifeline, a point of contact that brings hope, resources, and connection to a land that was once forgotten. The social impact of these projects is profound, opening up new opportunities for education and trade that were previously impossible for these remote and high-altitude communities. It took years of sweat and hard work, thousands of workers, and the best technology we have to turn this vision into a concrete and steel reality. Here, tradition and technology coexist, where the ancient winds of the plateau now carry the sound of modern jet engines across the high-altitude mountain valleys. Every curve of the building was tested in virtual wind tunnels to ensure it could withstand the hurricane-force gusts that frequently sweep across the high-altitude mountain ridges. The structural engineering of the runway itself is a marvel, designed to absorb the immense kinetic energy of a high-speed landing without cracking or failing over time. Even the glass is high-tech, providing the air traffic controllers with a clear and unobstructed view of the skies, regardless of the harsh and changing weather conditions. Precision is the name of the game, where even a few millimeters of deviation can have a significant impact on the safety of a high-speed takeoff or landing. The airport never sleeps, with a dedicated crew working through the night to ensure that every system is ready for the first arrival of the new day. Environmental protection was a core part of the design, ensuring that the operation of the airport does not contaminate the pristine mountain water or the local soil. Aerodynamics are pushed to the limit here, requiring aircraft that are specifically certified for high-altitude operations and pilots who have undergone specialized and rigorous training. Meteorological data is the airport's lifeline, allowing the staff to anticipate the mountain's moods and make critical decisions that keep the passengers and the crew safe. The airport is a gateway for life-saving supplies, drastically reducing the time it takes to deliver essential goods to those who live in the high-altitude regions. With every departure, we see the triumph of human will over the constraints of nature, a reminder that we are a species of explorers and builders. The beauty of the airport is matched only by the harshness of its environment, a place where high technology and raw nature meet in a spectacular display. Navigation in low visibility is a true test of the airport's electronic systems, which guide the aircraft with centimeter-level accuracy to a safe and smooth touchdown. It takes a village of experts to keep this facility running, from electrical engineers to weather specialists, all working together in perfect and constant harmony. As the day ends, the airport remains a symbol of human achievement, a quiet and powerful statement of what we can accomplish through cooperation and innovation. The vastness of the mountains is humbling, yet the existence of this airport shows that no distance is too great, and no height is completely out of reach. Mechanical engineering at this scale is about managing forces, from the heat of the sun to the weight of the planes, in a constant dance of stability. Invisible beams of energy are the airport's eyes, seeing through clouds and darkness to ensure that every flight path remains clear and safe for all travel. The focus required is intense, where every decision is backed by years of training and the most advanced technology ever developed by human hands and minds. Economic connectivity is the true power of this project, bringing the benefits of the global market to the most remote and isolated mountain regions on the planet. This is more than just an airport. It is a monument to human persistence and a beacon of hope for a more connected and prosperous world for everyone. The power of combustion is the only thing that can overcome the thin air, pushing the aircraft forward until the wings find enough lift to take flight. Data is the currency of safety in this environment, where every flight is monitored by a network of sensors and computers, both in the air and on the ground. Redundancy is built into every system, ensuring that even in the event of a major failure, the airport can continue to operate and keep everyone safe. Human communication is the final link in the chain, where clear and precise instructions ensure that every movement on the ground and in the air is coordinated. As the plane disappears into the distance, it leaves behind a legacy of engineering excellence and a symbol of our ability to conquer the most difficult terrain. The terminal is a melting pot of cultures and ideas, a place where the world meets the mountains and where the future of travel is being written today. Safety and security are paramount, with advanced systems protecting the airport and its passengers from both natural and man-made threats at all times and conditions. The beauty of the mountain airport is a reward for the hard work of those who built it, a reminder that engineering can also be a form of art. The quiet professionalism of the staff is the backbone of the operation, ensuring that the complex dance of aviation continues safely throughout the long mountain night. We conclude this report with a sense of awe, as we reflect on the incredible journey of building a mountain airport above the clouds and the mountains. Landing in this thin air requires specialized landing gear, designed to withstand higher sink rates and faster speeds than typical sea-level operations allow. Winter on the plateau is brutal, bringing blizzards that can drop visibility to 0 in seconds, testing the limits of the airport's navigation aids. Engines are pushed to their thermal limits during takeoff in the thin air, requiring careful monitoring and frequent inspections by the ground maintenance crews. The airport is built on land that holds deep spiritual significance, and the design respects the cultural heritage of the local Tibetan and mountain people. The runway isn't just concrete, it is a complex composite structure, reinforced with high-strength steel to resist the extreme forces of high-altitude jet landings. For travelers, the airport offers a view unlike any other in the world, turning a simple transit into a memorable experience of natural and man-made beauty. Standard operating procedures are modified for these airports, with special emphasis on engine performance, flap settings, and emergency escape routes through the valleys. Communication with the outside world is maintained through multiple satellite links, ensuring the airport is never isolated from the global aviation network. Safety systems are tested daily, with the emergency response teams maintaining a constant state of readiness for any situation that might arise on the runway. The surrounding topography is unforgiving, making every approach a precision exercise that leaves no room for anything less than absolute pilot perfection. Wind shear is a major concern, and the airport is equipped with LiDAR and radar to detect invisible turbulence that could threaten an aircraft's safety. Even in light weather, the mountain environment requires constant vigilance, as conditions can change from clear to dangerous in a matter of a few minutes. Logistics extend even to the cargo, which must be carefully packed to survive the rapid pressure fluctuations that occur during takeoff and landing in this region. Health is paramount, and the airport's medical staff are specialists in high-altitude medicine, ready to help both passengers and staff adjust to the environment. The interplay of light and shadow on the airport's structures is a daily spectacle, highlighting the unique design that was born from this extreme and high-altitude landscape. Modern materials science is what makes this possible, with alloys that can withstand the heat and stress of operating in such a demanding and thin atmosphere. Sustainability is integrated into the operation, protecting the pristine mountain environment that makes this location so special and unique for travelers and locals alike. From a distance, the scale of the achievement becomes clear. A man-made island of technology, sitting in a vast and ancient ocean of rock and ice. Crew coordination is essential, with every member of the flight deck working together to ensure a safe arrival at the roof of the world. The physics of flight are visible in every movement, as the plane battles the thin air to safely touch down on the mountain runway. Guidance systems provide a path of light through the darkness, a steady hand for the pilots as they navigate the complex approach to the airport. The ground turnaround is a carefully choreographed routine, ensuring that the aircraft spends as little time as possible on the ground in the harsh conditions. The airport exists in harmony with the local wildlife, with engineers taking care to minimize the impact on the natural habitats of the high plateau. Life at the airport continues with a sense of normality, despite the extreme altitude and the isolation from the world's larger urban and metropolitan centers. Space technology is a vital part of the infrastructure, providing the high-precision data that makes high-altitude aviation safer and more efficient for all involved. The airport is a gateway for many airlines, each bringing travelers to explore the wonders of the mountains and the unique culture of the Tibetan people. The world is now just a few hours away for the people of the plateau, a change that has opened up new horizons and possibilities for everyone. The roar of the engines after touchdown is the sound of safety, as the aircraft uses all its power to stop before the runway's end. Engineering for comfort in a cold climate is a specialized field, requiring efficient insulation and powerful heating systems to maintain a pleasant internal temperature. Every morning begins with a battle against the elements, ensuring that the runway is clear and safe for the first planes to take off and land. The invisible world of signals and data is just as important as the concrete and steel, keeping the airport connected to the global aviation network. Clear vision is essential for pilots, and every detail of the aircraft's preparation is handled with care by the dedicated ground maintenance and cleaning crews. The airport is a place of connection, where people from different walks of life come together in their shared journey across the roof of the world. Gathering data from the atmosphere is a continuous process, providing the meteorologists with the information they need to keep the airport's flight operations safe. The terminal is a landmark in its own right, a piece of modern architecture that stands as a symbol of progress in the middle of the mountains. Even in the darkest night, the airport is alive with activity, a beacon of safety and a point of arrival for those traveling across the plateau. Preparedness is the key to safety, and the airport staff are among the best trained in the world, ready for any challenge the environment might bring. The movement of goods is a 2-4-hour operation, ensuring that the local mountain communities have access to everything they need from the outside world. The science of aerodynamics is on full display in the mountains, where the cold, thin air makes the invisible forces of flight visible to the eye. The voices of the controllers are the pilot's guide through the mountains, providing the information and the direction needed for a safe and successful flight. Renewable energy is a vital part of the airport's commitment to sustainability, reducing its impact on the delicate and beautiful mountain environment it calls home. In the thin air of the plateau, these sensors are the pilot's most important tools, providing the data needed to navigate the complex and high-altitude atmosphere. The experience of flying into the mountains is one of awe and wonder, a journey that offers a unique perspective on the beauty of our planet. The runway is a feat of engineering, a perfectly level surface in a land of extremes, and a lifeline for the people who live in the mountains. As the day ends, the airport remains a quiet and powerful statement of human achievement, a bridge between the world and the roof of the earth. The connection between pilot and machine is vital here, where every movement is a calculated response to the unique challenges of the mountain environment. Safety is a constant commitment, and the airport's emergency teams are always ready to protect the lives of those who travel through this unique facility. Modern travel is about efficiency and convenience, even in the most remote locations, and the airport is equipped with the latest and best passenger technology. The roar of the engines is a reminder of the power required to conquer the mountains, a triumph of engineering that has transformed the way we travel. The tower is the brain of the airport, the place where the complex dance of aviation is coordinated with precision and care for the safety of all. The moment of touchdown is a culmination of a precision journey, a successful arrival at one of the world's most challenging and beautiful airport locations. Even the smallest details of the airport's operation are handled with care, ensuring that the facility is always clean and welcoming for all travelers. The runway is a path of light, a steady guide for the pilots as they navigate the darkness and the cold of the high-altitude mountain plateau. Trust and coordination are the foundation of flight safety, especially in the demanding and unpredictable environment of the high-altitude mountain airports. The beauty of the journey is matched only by the scale of the engineering achievement, a reminder of our ability to reach for the sky's highest heights. Technology provides a clear picture of the skies, allowing the controllers to manage the flow of traffic with safety and efficiency in all weather conditions. We are proud to have been a part of this incredible project, and we look forward to the next challenge that pushes the boundaries of engineering further. The mountain airport is a silent monument to our ambition, a bridge between the earth and the heavens that will stand for generations to come. With every takeoff, we are reminded of the power of human ingenuity and the spirit of exploration that drives us to conquer the impossible daily. Cintech Industries, engineering the impossible. Thank you for joining us on this journey above the clouds. We'll see you in the next technical report series. Advanced materials are the unsung heroes here. With titanium and specialized alloys, ensuring the aircraft survives the high-altitude landing stresses. Security at the roof of the world is a multi-layered system, blending high-tech surveillance with the natural barriers of the rugged terrain. The airport is a critical link in the global healthcare chain, bringing life-saving technology and medicine to those living in the most isolated areas. Automation plays a key role in maintaining the airport's infrastructure, ensuring that safety-critical systems are always functional, even in freezing weather. The digital infrastructure is just as important as the physical one, with real-time data allowing for predictive maintenance and enhanced operational safety. Digital tools streamline operations, allowing for precise management of resources in an environment where every single minute and every kilogram counts. The architecture is a functional response to the climate, blending form and utility to create a structure that can survive the harshest winters. Inside, the environment is carefully controlled, providing a warm and safe haven for travelers as they prepare for their journey through the sky. The juxtaposition of the old and the new is a recurring theme here, where modern technology meets the timeless majesty of the high mountains. Energy independence is a goal for these remote facilities, using the power of the high-altitude sun to keep the airport running day and night. Aviation is a field of precision, and the lighting systems provide the visual cues that are essential for a safe approach in low visibility. Airlines from across the country fly to these mountain airports, connecting the plateau to the cultural and economic centers of the modern world. Protecting the environment is a core value, and the airport's infrastructure is designed to minimize its footprint on the delicate high-altitude ecosystem. In bad weather, the airport's electronic systems become the pilot's primary guide, providing a safe and reliable path through the clouds and the rain. Though isolated by terrain, the airport is a vital node in the global network, a place where the mountains meet the rest of the world. The runway is a symbol of our ability to transform the Earth, a testament to the skill and the dedication of the engineers who built it. Safety is built into every procedure, with multiple checks and redundancies to ensure that every flight is as safe as it can possibly be for everyone. As the sun rises, the airport begins a new day of operations, a cycle of travel and connection that has transformed the lives of many. We leave you with this image of success, a reminder that with vision and hard work, even the highest mountains can be conquered for humanity. Cintech Industries, we are the architects of the future, building the infrastructure that connects our world, no matter how difficult the terrain might be.